Welcome back to another AP Calculus video. This is part 2 of topic 2.13 of exponential and log equations, inverses, and inequalities. In part 1 we looked at more of the equations and inequalities. This one we'll go over inverses and inequalities. So let's get started. So this is just talking about the general forms of exponential functions and log functions. So that's what they'll look like. Finding inverses. So finding inverses of log and exponential functions, we're given a set of steps here. So let's go ahead and use those steps into example 1. So first is to switch the roles of x and y in the equations. Okay, so this right here is y. So we're going to say it's x now. So x is equal to 3, 2, and then we have x here, which will change that with y. So y minus 4, or is it plus? Y plus 4, and then minus 15. And then now, because we're still trying to solve for, the inverse equation, we're trying to solve for an equation, it has to equal to y, because an equation is y is equal to whatever the equation is. And so, we have to solve for y, so we can start to isolate. So plus 15, 3, 2. Now we can divide 3. And now we have that 2. So I can rewrite that. Y plus 4. And I feel like there's probably more than one way to solve this, but what I can see that it's currently in a log form. This is one whole term right here, right? It's not a log, it's in an exponential form. I can see that's in one term, and so that's our a, which is equal to b to the power of c. And so I'm gonna go ahead and change that into log form. This is our a, this is our b, and this is our c. I'm gonna go ahead and change it. Log b, that's 2, b, and then this is a, and this is equal to c. See, sometimes I even forget. And so that entire thing inside, which is equal to c, which is y plus 4. And now it seems easier to solve for y now. Now we're gonna minus 4, and then minus 4 on this entire thing. So it looks like y is equal to log 2, 15, 3, minus 4. So that's our answer. But it says inverse. We don't want to put y. So, oops. Oh, it's still in a race. We would put the inverse, which is a negative 1, and then x. So that's our answer. And just so you know, with logs and exponential function, the inverse will always be the other one. If it's a log, the inverse will be exponential. If it's an exponential, the inverse would be a log. But that is basically how you do it. I completely forgot about these steps up here, but you can read that if you want to. So example 2, we have this. So let's go ahead and switch to x and y. So x is equal to negative 3 log 5 y minus 4 plus 6. So let's go ahead and start doing that. Negative 3 log 5. And we can divide it by negative 3. That's okay. Looks like this right here. It is a log. This is our c, this is our b, and this is our a. So we can change it into an exponential. Let's see, our b is 5 to the power of c, which is, that's quite messy. Right, and then that equals to a, which is y minus 4. Now we can plus 4 this entire thing, and then y is equal to 5 to the power of this plus 4, and then I will erase the y, because make sure we gotta put the correct thing. Negative 1x. So that's our answer. Now the next one looks like it's not asking for the inverse, so let h of x right here and let k of x equal to this. For what values of x does k of x equal to 1? Okay, so we're told that because k of x is equal to 1, but we're also told in the question that k of x is also equal to the inverse of h of x, which we are given. So basically, we can find out the inverse of h of x by, switching the x and y, and then solving for x, because we know that the y value for h of negative h of x is equal to 1. We would have to solve for x. But that is kind of long, and you kind of already see, you can do this simpler. It's a trick. You can see that because h of negative 1 is x, we are already given like a y value of the negative h of x. That means that 1 has to be in like one of the values of h of x itself, right? So if we draw a table here, this is the x value, and this is the y value, right? I'll have the negative, this is the negative side, and then this is the normal side. We know that this is basically y, by the way. So if this equals to 1, we can put 1 here. But the inverse is always the like switched around, right? So that means y, or 1 is up there. So that means that h of 1 is going to equal whatever the x is inside of that. Hopefully that makes sense with the table I drew, because then if you plug in x, right, we can solve for this y, right? H of 1 will solve for this y value right here. We don't know, but that y value would be the x value of the inverse equation, which is this. So we can just use the h of x equation. We don't have to solve for the inverse. We use this and plug in x for 1. So let's go ahead and do that. X is equal to 1, and that's 3 to the power of 2 minus 2, that's 9 minus 2, so that's equal to 7. So h of 1 is equal to 7. Yeah, so this x is equal to 7. H of negative 1 is 7. Will give us 1, but that also equals to k of x, and so that means it's k of 7 equals to 1, and it said solve for what value k does k of x equal to 1, and it's 7, so the answer is 7. So now solving inequalities involving log and exponential functions. So let's go ahead and do that. So we're given f of x, and what are all the values of x for which f of x is greater than 0? So we can go ahead and equal this to 0 to solve. Is equal to 0. But now because there's two separate, I can add this one to the other side. So I'm gonna go ahead and do that. Alright, and now we have them equal to each other. Here is where we want to find out the domain. I don't think we want to do it up here, because when we do the domain, we want to make sure that there's like one on each side. So the domain for this one's quicker. So this one is going to be x is greater than, remember it always starts with greater than 0 and then solve for x, so that's negative 3. And then for this one here, we got to do this. What multiplies to negative 4 but also adds to 7? 7 is a prime number, so we're going to have to use the quadratic formula here. So I'm going to go ahead and do it up here because there's more space. So I'm going to write the quadratic formula. Right? That's the quadratic formula. Now I'm going to plug in the values. Okay, I might be writing a bit too small. Now I'm going to do inside the radical, which gives me 16 minus 28. That's over 2. Okay, so 16 minus 28. That gives me a negative number. So we know here this is square root of negative 12. 4 divided by 2, that's equals to 2. So technically it's just 2 plus or minus the square root of negative 12. But remember from like algebra that a negative or a square root of a negative number, that gives us an imaginary number. So this is not really, it's not a real number. So I think we can just ignore this one, and then we'll just use this domain right here. So we don't have to worry about this. Just look at that domain right there. So let's go ahead and continue with our equation. Now we can solve both sides. Get rid of the log. Gonna move everything to the left side. Plus 4. What multiplies to negative 5 but adds to 4? Looks like it's negative 4 and negative 1 is equal to 0. So that gives us x is equal to 4 and x is equal to 1. So now we want to test for what are all the values of x for which f of x is greater than 0. So we want to create the, I don't know what it's called, but basically the number line, right? And we kind of want to put the values that we got. We got 1, and then we got 4, but then we also have our domain restriction, which is negative 3, right? And basically, the reason why we want to do these number lines is because we want to know what's going on at x is equal to 4 and x is equal to 1. So we know that is the y value going to be greater than 0 or not. So if you remember back in like, I think it was like unit 1, we use this number line to figure out like the negatives and positive. So we're looking for greater than 0. So that means we're looking for the sections that have a positive. And so we can choose any number between negative 3 and 1. So I'm going to go with 0 because that's the easiest. And 0 and 1 to 4, I'm going to do 2. And remember, we still have to do the sections out here, which go into negative infinity and infinity. This section, I'm going to choose 5. This section, we actually don't have to choose anything because that right there is our domain restriction. Every x value has to be greater than negative 3, so we don't have to worry about anything back here. So we got to do this. But also, I guess I kind of just put the negative 3 to show you how the domain restriction is blocking everything there. Technically, yeah, you don't have to put that into the number line. It's just these two numbers because that's what we got. And so when we plug these numbers, we want to plug them back into this equation right here, see what they get. So if we do 0, x minus 0, x minus 0, or sorry, 0 minus 4 is negative 4 times 0 minus 1, that's negative 1. So that gives us a positive. So I'm going to write pause. Now, what's the next number? The next number is 2. So 2 minus 4, that's negative 2. 2 minus 1, that is 1. So that gives us a neg, short for negative. And then let's see. 5 minus 4 is 1 times 5 minus 1 is 4. That's positive. So it looks like this section right here and this section are both positive. So we know that it's this number and this number. And if we look back to here, it says only greater than 0. So we're not going to include the numbers that are on that we use like for our dividers, right? So our answer it should be open. A parentheses is for open. -3 to 1, and to write and, you write the U. 4 to infinity. And so that is our answer. Hopefully that makes sense. So moving on to example 5. Let g of x equal to this and let h of x equal to this. What are all the values of x for which g of x is less than h of x? So now we can set it up like this. So g of x, which is this, is less than h of x, which is this. Let's solve for our domains. So change it to blue here. This would be x. What looks like this one, I have to use the quadratic, so I'm going to do this first. X is greater than -4. So let's move this over and use the quadratic formula. Here you can reference up here for the quadratic formula, but I'm not going to write it again, so I'm going to write it down with the values inside. That gives us -1 plus or minus the square root of 21 over 2. So this gives us two values, right? We have the plus and the minus, so -1 plus the square root of 21 over 2, and -1 minus the square root of 21 over 2. We have it, let's see, greater than 0, right? So x is greater than, you would, I guess. But the thing is, because this one right here is minus, you would have to change this one to x is less than. If we draw a line right here, this is 0. I don't know the exact value, so we can kind of estimate the exact value. The square root of 21 right here, it's close to square root of 16, so it's going to be a little bit over 4. So let's say it's like 4.5 for now, something like that, right? So -1 plus 4 is like, so it's like 3, so 3 divided by 2. 3 divided by 2 is 1.5, so it's like between 1.5 and 2. So that is going to go like somewhere here, right? And then this one, -1 minus 4 is around -5 divided by 2, which is like 2.5. So it's between like -2.5 and -3, so it's going to be like right here. Yeah, so based on drawing this, it would just say that numbers here and here are good, but here and here aren't. That doesn't really tell us why I had to change this right there, but I'm thinking because this is a negative. But yeah, that's what it says. I cannot expand on that, but I guess we'll keep moving. This, and this is our domain restriction, and so let's solve now. So we can take away the log. So when we solve for x, we can change that into an equal sign now just to solve for x. So let's go ahead and do that. So that gets away. So it's x squared minus 9. So x plus 3 and x minus 3, that's equal to 0. So x is equal to -3 and x is equal to 3. So now we can do the number line to see where g of x is less than h of x. If we make our number line here, we can put -3 here, 3. And remember, this one was like -2.5 to -3, so I'm gonna say it's like around here. I'm gonna put a squiggly line because it's like approximately, you know. And oops, I undid it. This one, the positive one, it was around, I think it was 1.5 to 2. Don't remember exactly, but I'm gonna just write a squiggly there. And you know, like 0 is there. I don't have to write 0. That's where this is. This is here, and this one is here. Hopefully it doesn't like disrupt if you're like looking up there. Now we can put the values in, and up here we had -4, which is here, -4. but it has to be greater than, right? So everything behind it is there, and it's not -4 either. So let's go ahead and get a value for each. We can put -3.5 there. We can put negative. We don't know the approximate values for these, so technically we can use the help of this to know is that positive or negative to change the sign or keep it the same. If we look back into our equation back here, they're both to the power of 1, so that means we can sign change. I think this was back in unit 1 again, that if it's, I guess, odd, you can sign change this. If this is positive, this is negative. But if it's an even exponent, then you cannot sign change. It'll be the same thing. Then because they're like this spot is not next to this spot, technically it's not gonna. If this is negative, this won't be positive. We have to check it again. Technically, they're separated, not together, so you cannot just directly sign change that. So yeah, hopefully that makes sense. Let's go ahead and do this, but before that we can put a value here. Yeah, I don't really know that value, so I'm actually gonna plug in a number there. So I'm gonna do 5, but yeah, whatever this one is, and then I can sign change to this section. Let's go ahead and do this one. -3.5 plus 3, that gives me -0.5. -0.5 multiplied by -3.5 minus 3, that's -6.5, which ends up being a positive. So this is pos. Now, if that's pos, then this is neg. And then we're going to do that. 5 plus 3 is 8, multiplied by 5 minus 3, which is 2. That's positive. So sign change this. That's negative. So negative, negative, positive, positive. And we want to know where g of x is less than h of x. So we're looking for the negative sections. So it looks like our answer is going to be -3. We're not going to count it because look at that, it's no equal. Comma. This arrow, we're going to trace it back, goes to this one. So -1 minus square root of 21 over 2 u, and this comma or this arrow trace back to this one. Kind of messy, sorry guys. Plus square root of 21 over 2 and then to 3, and then that's our answer. Okay, so example 6, this one is easier. I think it's easier. So it's less than, k of x is less than or equal to -31, so let's do that. So less than or equal to 31. We can already write that, and then we can just solve it. Really, we can just solve it, but we do have to check where we just solve for x, but then we have to check where it's the y value of that x is less than or equal to -1. So let's go ahead and solve it. That's 30. Oh wait, it's -31, my bad. So that's -32. So now we're dividing, and we're dividing by a negative number, so that means we have to switch our sign there. So 2x minus 3. Oh, I didn't even switch it. Switch the sign. That's +8. We can, because this is here, I don't want to change it into log form. We can change this to have a base of 2. So it can be 2 to the power of 3. That equals to 8. So yeah, I'm going to X that out. So now I can just do these two. So x minus 3 is greater than or equal to 3 plus 3 plus 3. So x should be greater than or equal to 6. X is greater than 6. So I think that's already the answer. I don't think you need to check in a number on the x values is going to be greater than or equal to 6 for when the y value is less than or equal to -31. So to change this into like the parentheses form, we know it can be equal to 6, so we do the bracket and then it goes greater than 6, so it goes to infinity. So that's our answer. So this is the extended notes part. related to the FRQ, so you can read that. Pause the video and read that if you want. So we're gonna go ahead and start with number 1. So solve for when f of x is equal to this. So we're gonna plug in f of x for this. So e of 1/2. Because it's a fraction, we can do the butterfly method or just multiply that to both sides. And because we're multiplying these exponents, basically just adding, so 1/4, actually I'm going to do a different color there, 1/4 plus 1/2, which we can multiply both sides, which equals to 2/4, so that's 3/4. So this right here changes into e to the power of 3/4, and so e to the power of 3/4 is equal to this one right here. We will move that. But this is basically the same thing as just e to the power of 5x, because remember, exponent to exponent, it would, you'd multiply. That was kind of messy, sorry. But now, because we have the same log, we can just solve with these two. So take that out. So 3/4 is equal to 5x divided by 5. This right here is dividing, so we can change it to multiplication, but we need to do the reciprocal of that. So that's 1/5. That's 3/20. So looks like that's our answer. Now solving for 2. G of x is equal to this, so we'll replace g of x there. So 3e is equal to 8e 3x minus e. So we can isolate. That's 4e is equal to 8e 3x. We can divide 4 on both sides. It'll be 2. We have e right here. I think the trick for when you have e, we're gonna multiply the entire thing by ln. So when we multiply, this is ln e, and ln e is basically log of e, right? And whenever the base and the value of a is the same, it's going to always equal to 1, any number. So we can basically just write 1 is equal to ln2 plus, looks like this value right there. So I'm going to write ln e to the power of 3x, but because it's the power, we can move it to the front. So I'm going to do that. So 3x times ln e, and again that's 1, so we can just erase that because it's 3x times 1 basically. So we have that, and now we want to solve for the x, right? So let's isolate that. So 1 minus ln2 is equal to 3x divided by 3, and so it looks like 1 minus ln2 3 gives us our answer. So that was 2.13, and 2.13 is a pretty difficult topic in Unit 2. But then it, like 2.14 and 2.15, I think they get kind of different. But yeah. So thank you so much for watching, and hopefully that really helped.